welcome to another session in General Chemistry 2. I'm your host, Sir Picaro. I'm going to discuss for today a mini lesson connected to amorphous and crystalline solids. And shoutout nga pala sa aking mga estudyante ng grade 12 STEM under Sir Julius Ray Rosa. Okay, just like what was said earlier, I'm going to discuss here in this mini lesson yung difference between crystalline and amorphous solids. And as an added perks in this mini lesson for watching, in a part of this mini lesson, I'm going to pose a question wherein if you get the correct answer, you can use it as a password in a Google Drive file that will serve as your reviewer in Chemistry 2. Okay, let's now focus on the topic at hand. This is MELC number 5, describing the difference in structure of crystalline and amorphous solids. So let's describe first crystalline solids. Imagine a city where every building is meticulously planned, streets are laid out in a precise grid, and everything has its place. This city is akin to a crystalline solid. At the microscope level or the microscopic level, crystalline solids boast a highly ordered structure where atoms, ions, or molecules are arranged in a repeating pattern that extends in all three spatial dimensions. This regularity is similar to a well-organized lattice or grid. So that's how you should describe crystalline solids. And how about amorphous solids? Now think about a picture where a town where buildings are placed haphazardly and streets wind in unpredictable directions and there's no clear pattern to the layout. This town represents an amorphous solid. Unlike their crystalline counterparts, amorphous solids lack a long-range order. Their particles are arranged more randomly and do not form a repeating pattern. This structure is more like a jumbled, disordered heap than a neat grid. Okay, that's our description for crystalline solids and amorphous solids. And most of the time for amorphous solids, they are the ones which exist as powders. Okay, and for the crystalline solids, I think the most common example would be diamond. Okay, let's now have the key differences between the two. In terms of order, crystalline solids are defined by their long-range order while amorphous solids lack this regular arrangement. So just like what was said earlier, crystalline solids usually has their lattice configuration, while amorphous solids lack this particular arrangement. In terms of melting point, because of their orderly structure, crystalline solids have very sharp or higher melting points than amorphous solids. While on the amorphous solids are softer over a range of temperatures, gradually transitioning from solid to liquid. So when you use X-ray diffraction or a diffractometer, crystalline solids produce distinct sharp patterns in X-ray diffraction because of their very orderly arrangement, whereas for amorphous solids, they yield more diffuse patterns and reflecting their lack of long-range order. In terms of physical properties, the regular structure of crystalline solids results in distinctive cleavage planes and anisotropic properties, meaning their physical properties vary depending on the direction of measurement. Amorphous solids with their irregular structures tend to show isotropic properties, remaining consistent regardless of measurement or direction. That's for their physical properties. So in terms of the simpler terms, when you say crystalline solids, so usually there are points wherein crystalline solids will be stronger, especially if you will hit a weaker point of their lattice or their orderly arrangement. So just like when diamonds, somehow if you strike a softer part of the diamond, they tend to break. But it's very hard to target a particular section because it's very small. Sometimes it's very small. While for the amorphous solids, they tend to break easily because and that's why they are forming easily the powders or the powder form for amorphous solids. Okay, we have now reached the part wherein you may now answer this one. There is a picture here using what we have learned in the classroom. Try to get the name or the IUPAC name of the structure. And after that, after getting the name, try to classify it whether it's aliphatic or aromatic. And then that will be, if you combine it and use small letters, if you get the correct IUPAC name and also the correct classification whether it is aromatic or aliphatic, then you will get the correct password. And for the problem solving activity, you can write your answers in your notebooks. Okay? Okay, for the last part of this mini lesson, so try to answer this one, and your reflection should be posted in this YouTube video under the comment section, and for you to be able to validate your scores and your additional points, try to like my video, okay? Laging tandaan, sa PIQ'S TV, panalo ang natuto.